So IFC. Who here is involved with IFC on a regular basis, exporting out? Okay. How many just hit the export button? It's a few. Yeah. Thanks for being honest. Okay. So today, what we're going to cover, I'm going to start off with talking very briefly about what IFC is. Then going to look at why we need to use IFC in the first place. This is a Revit user group for sakes anyway. And how ultimately do you export a decent IFC from Revit? Is it even possible? And then we'll just conclude a few things as well. So IFC, well, it stands for Industry Foundation Class. It's a global standard designed for the sharing and exchange of construction and facilities information. It's a vendor neutral format, which means it's not owned by anybody, regardless of what you hear people say, and it's currently being developed by Building Smart. So this is IFC. This is in its text-based format. So this is IFC step. This is also IFC as well, in terms of XML. It's not the best IFC in the world, that one. But this is also another example of IFC that you might be more familiar with, the geometric sense. But also, this is IFC as well. This is Kobe. I'm sure a lot of people are familiar with something like this. And this is a subset of IFC, meaning it's a small section of the data that can be provided within an IFC file. And this is IFC. So IFC is essentially a relationship database. So it deals with kind of parent and child relationships. So if we think about a building as an example, we have the site, and then belonging to that are the individual buildings or facilities, and then we have building stories, and then further down to that we have spaces and elements that sit within those spaces as well. So within IFC, all these elements can relate to the elements up and down the tree. So IFC itself isn't designed for round tripping, certainly not 2x3, the current version that a lot of people use across the industry. Versions 4 and 5, the versions that they're currently developing at the moment, they are looking for those to be potentially used for round tripping. By that I mean that you can export it out from Revit, for example, and import it into Revit and still get decent usable output. It's essentially for the export of information from, say, Revit, and then importing it into another software, Tekla, or even something like ArchiCAD. So why do we need to even bother with IFC in the first place? Well, very simply, it's regarding interoperability. I'm very much an advocate of OpenBIM, ensuring that we're not tied into one particular software. It doesn't necessarily provide the best benefits on the projects. The whole purpose of OpenBIM and IFC is that we can maximise we can choose the pieces of software that are ideal for the particular use. So structures, for example, Revit structures may not necessarily be the most ideal software. And essentially, yeah, we don't live in Revit world, so we're not going to deal with everybody who's using Revit. You might be lucky enough to work on projects where you have MEP structures and architecture all working with Revit, but certainly when it comes through to fabrication, that's not going to be the case. IFC is an established standard. It's been around for over 20 years, so it's tried and tested. Certainly the IFC 2x3 standard has been around for a considerable time now. And comparing it to other formats like DWG and FBX that you might use for transferring geometry, there's also a significant amount of data loss within there. So IFC is a very good file format, repository for carrying that information from A to B. So how? Well, I strongly advise using the IFC Exporter inside Revit. It's a freely available plugin from Autodesk, which is unusual. and it adds significant amount of functionality. It's basically a necessity if you want to do IFC inside Revit, in my opinion. So if you install this, you go into Revit. So Revit, you go down to Exports, and you can select the IFC. It will open up the IFC dialog. And it's not just a case of this front page. There are additional settings as well. And just hitting export, for all those that put their hands up earlier on, that just won't do if you want a decent IFC. It's not a kind of, it's not hit and hope. It really does require using these settings, and also a lot of additional ones as well, which we'll go into. So even if you've never exported an IFC before, it does give you some options to assist you. And these are model view definitions, or MVDs. These are setups that predefine the way that the IFC exported into certain different formats. And these formats are used for different uses. So an MVD, or a model view definition, it's a subset, or potentially all or part of the IFC file, or the IFC schema, and it's for a particular purpose. So the extended handover view definition, which is one you might be familiar with if you're working with Kobe, this is essentially a subset of the IFC that relates to the handover of facilities information. And some of these additionally are specific for the use of geometry as well. So you have the ones that are certainly kind of IFC form, even though very specifically named, like design transfer, but there are also ones that exist in 2x3, the coordination views. So defining an MVD on your project, what information you want to export and what you want other people to receive is fine, but you need to control the data that actually leaves your project, and it ensures actually it complies with these settings or these standards that you're trying to define. And you can do this with the IFC exporter. Some of the things are out of the box, and other things you have to control yourself, such as the class mapping, layer mapping inside the IFC, and also classification assignments and data mapping as well. Just about this presentation, you don't have to worry about making notes, or it should be available. If it's not fully available on MRUG, it's available on the AU website. Okay, so sorry, that was a slight sidetrack there. So classes, when we refer to classes and kind of class mapping, pretty much everything you see or use inside Revit in an IFC sense belongs to a class. A class is essentially, it's a collection of data or objects that have a kind of similar use or a similar kind of definition. For example, doors would belong to one particular class. So you can kind of think of classes, or IFC classes, like categories inside Revit. It does extend a lot further than that, but the very simplest sense, that's kind of a good way to think about it. And if you don't define these classes when you're exporting out to IFC correctly, then the information you're actually exporting won't necessarily be the information you want to export. So what we have in this example, we have two items here. Maybe. It never works on screens. We've got two doors here. One of them is defined in IFC terms as a door. The other one is defined exported as a window. If you can see on the bottom, we have similar kind of properties for each element, but there's certain property sets or certain sections of data or attributes that are specific to a door, and some are specific to windows. So you can see in this example here alone, if you incorrectly map something as an IFC window as opposed to a door, there'd be things like your IFC door panel properties that wouldn't necessarily be exported or mapped out to the IFC. So mapping, class mapping is extremely important inside Revit, and it's not something it does particularly well out of the box. I'm going to explain why. But if you want to understand all these IFC classes, or at least understand the ones that map to Revit categories or elements that you're working with. The best place to look is the Building Smart website, is the reference, the link. It's not the most user-friendly of locations. I think it's designed more towards coders and developers rather than end users. But if you get used to it, it is relatively easy to kind of navigate. This link is probably one of the best places as a starting point. So you have a list of some IFC classes here for different elements. If you click on one of these, it takes you to a page that tells you all about that particular element and attributes that are associated to it. There are particular or specific collections of data known as property sets. Some of these are specific to particular elements, and you can click on these, and within those it'll expand out and show the properties that are available for that particular property set. So as this is an example for a space heater, so you can see the parameters that will map out to IFC. I think the IFC can contain by default are things like the body mass, the output capacities, and the thermal efficiencies. So by default, within the IFC standard, there are hundreds of objects, hundreds of elements, and of those there are some objects or elements have multiple property sets, each one of those containing like 10, 15 different parameters as well. So even before you start trying to define what parameters you might want to use on a project, there's already those there that you could use if you wanted to. So as I said before, it's a very well established and well documented standard. It covers everything from architecture, structures, MEP, and certainly as they move into new standards, IFC 4 and developing into 5, there will be additional items in there that will cover things like infrastructure and landscaping and other items like that. So if you look at the actual object types, or the element types, again, looking at a space heater as an example, it also identifies the additional kind of subtypes or enumerations that can exist for that particular object. So looking at this space heater, it defines the subtypes, or as I said, the enumerations for that particular element type. And this information is really important, as we'll come on to later on. So class mapping, it's particular. Do we have any MEP people in here tonight? Okay, we've got a few. Great. So certainly for you guys, it's absolutely crucial because Revit's categories aren't exactly the most expansive, especially for kind of MEP. So if you look at kind of mechanical equipment as a prime example, you'll have many different object types that will be assigned as a mechanical equipment category. But when you export this out to another file format, you want to be able to tell people what these objects are. Now, in certain instances, it's about naming conventions and family naming conventions, etc. But as I said before, IFC is a very established file format and has many different object types defined. So as an example here, mechanical equipment could be a boiler, a fan, or a radiator, and all these have individual IFC classes and individual IFC types as well. So there is supposed to be a quick and easy way to kind of export or out and ensuring things are export out correctly to classes, and that is to there's an options. You can go to export options and IFC options, and you can see a list of all the Revit categories and Revit subcategories, and you're supposed to be able to input your IFC class in there, and it'll export out to that. Blah blah blah. That doesn't work. Certainly in all the versions I've tested, I think somewhere down the line it kind of stopped working and nobody really kind of picked up on it. In all fairness, it's probably not the best method, and this way is far superior anyway. This is an elemental level as opposed to the subcategory level. And essentially the way you can do this is by adding 2 parameters to your project. You can actually get away with adding 1 parameter, one called IFC Export As and one as IFC Export Type. And within here, using the Building Smart website as a guide, you can import your IFC objects or IFC element types, and you can the type for the particular elements in there as well. You can define these, and that when you export these out using the IFC exporter, it will export these out as a particular element, and will allow you to map the property set information to that as well. So what I strongly advise if you're building content libraries for your organizations is to include the IFC mapping inside that file. The only point where that may become a downside is further down the line when potentially the version of IFC will change and you go from IFC 2x3 to 4, and there might be some variations for that particular for certain elements. But certainly this is a really good kind of starting point and saves a lot of legwork on your projects. So Revit component elements inside Revit, things like your doors, your AHUs, your columns, and various other basically things that you can go into the family editor and start tinkering with. All those things will map to pretty much any kind of object, IFC kind of building element. System families, however, don't. It's primarily because of the way that Revit codes system families. It's very different. If you use Dynamo or any stuff with the API, you'll understand that there's a discrete difference or variation between the system families and component families. And you need to be aware, whereas you can export a door out as anything you like as a radiator, ceilings will only ever export out as a IFC covering. And IFC coverings cover any kind of finish, so a wall finish, a floor finish, roof finish, etc. Similar with roofs, they will export out as a roof, or again, can't recall whether they will actually export out as an IFC covering, but certainly you're very limited. And what I'm trying to say is, if you work in an organisation where you use a lot of Revit hacks, where you use curtain walls to represent stud work, for example, that's probably a really bad example because they've just made some changes in the IFC exporter that will work for that. But certainly if you're using it for things like handrails, that sort of thing, you won't be able to export out to the correct IFC class or IFC objects. There are multiple ways, as I said. You can do it in 2 parameters or just 1. So if you're doing it using 1 parameter, the IFC export as parameter, you can enter it, so you've got electrical appliance type, and then put a full stop, and then the type behind it. Or you can enter it over 2 lines and use the IFC export type parameter. And as an example of the sort of thing that you see when you export it out to correctly, you'll see in this instance that it comes through as an electrical appliance inside sleeve roof, and it's identified as a water heater. And that's the sort of thing that you get if you export something out correctly to IFC. So looking at layer mapping, so Revit doesn't use layers in the conventional sense. It uses categories. I'm sure you're all aware of that. But there are other software, pretty much every other software out there uses some sort of layer or level convention, depending if you come from MicroStation or Bentley. Essentially, they're a way to kind of customize or subdivide your model into efficient areas. Obviously, Revit is the kind of hard-coded categories from the very start. But when you're working with these other organizations or these other softwares or platforms, it's important that you use layers, because, or you at least export things out to the correct layers, so when it comes out to these other platforms, that they can import it and work it and use it successfully. Again, out of the box, it will put things onto layers, so it won't just stick everything onto layer 0, for those that have come from kind of AutoCAD. By default, the template aligns with BS 1192 1997 and the CSI FB standards. So that will give you something that, yeah, you will be familiar with, but it's a very old standard. It's 20 years old now, so really we should kind of bring this up to date and use kind of Uniclass 2015. This will tie in with other standards that you're working on, especially if you're working on kind of a government standard or where your client's defining Uniclass as a classification system on your particular project. So essentially, here we've got some examples where we've kind of updated the BS 1192 up to a Uniclass equivalent. So this layer mapping is done through a text file or a kind of a layer export file. And like a lot of the text files that kind of link in with Revit for additional settings, this is tab delimited. Here's an example of one down here. It's broken down to category, and then it's then broken down to the layer name, the layer color, and then you have the equivalent again for if it's cut or projection. If you are going to create these or amend these, I strongly recommend using Excel. It's far easier, certainly in terms of the representation, and you can benefit from the automation, and certainly kind of the cutting and pasting. So as I said, like these are defined in like text files. You can ensure that your Revit uses these text files when you export out by changing these particular lines within your Revit INI files, your variables. If you speak to your BIM manager or the person that sets up these, then they'll be able to assist. If you are the BIM manager, then this is the sort of thing that you should be standardising across your organisation. Again, just as a quick note, if you are going to use paths inside here, it's always recommended to include them all within quotation marks as well. So as an example, similar to the class mapping, we can use overrides. So if something doesn't necessarily need to sit inside the default one that we've defined within that text file, we can define a parameter called the IFC presentation layer, and we can input the override or the layer override there. And here's an example where we've used that and it's exported out to the appropriate layer inside Solibri. So data mapping, probably the most important in terms of what we do. Kind of BIM is key, so data is key when you're working on BIM projects. It's all the location of the information within the IFC is almost as important as the existence of the data in itself, especially if you're familiar with using Solibri, for example. Navisworks, that's another example. Nobody likes to play hunt the parameter. You've got to find it under the correct group that it's exporting out, or the property set. It's a bit of a pain. So using data mapping within IFC and the exporter, you can ensure that this information goes out into the appropriate places. So in terms of BIM uses, the data within the IFC is crucial, and even more now in terms of kind of interoperability and the more tools that we're using. A lot of people are moving away from just the Autodesk suites and using things like Solibri, Synchro for sequencing, generating federated Kobe through things like XBIM, BIM Server, Solibri, as I said already, and also as well importing into CAFM systems. The facilities managers at the end of the day can take the IFC or the derivatives and import that in. So the location of that information is really crucial for those guys. The IFC exporter by default will map some information. It won't necessarily map everything, but you can define where you want all this information to be or to go. So as an example here, I have a room and I've defined within Revit, and these are the out-of-the-box properties. I've defined a whole bunch of these, and the IFC exporter will cleverly or handily, whichever way you look at it, will map a lot of this information out into the Calibri file, or the IFC. So here we've got an example where you can see all the data is kind of mapping over and going into an appropriate place. So you've got quantities, you've got finished data, and you've got the room identification information, things like room numbers and names, and the layers are in there as well. As a standard kind of out of the box, you can override some of the kind of the default ones that you just saw, and these apply across many objects. So you've got things like your IFC description, your IFC name, long name, object types, and sometimes you probably need to play around with these within your own organisation to understand kind of how it works for you and kind of what information kind of maps where. But majority of instances, you'll probably want to ensure that the IFC short name or the IFC name and the long name are correct for the particular objects you're exporting, especially for things like building story levels inside Revit or IFC building stories, and descriptions as well. It doesn't always export the right description, but you can absolutely define what the description of that particular object or element is going to be. So as I showed earlier on in terms of the Building Smart website, the IFC does have predefined property sets. Using doors as an example, there are three. There's the door window glazing type, which is kind of very nicely skewed. There's the door window shading and door common as well. Some of these are shared across multiple object types. So the one that says door window glazing type is shared with windows as well, so that's kind of a shared bit of stuff. So we can, just as an example for doors, you can see that there's a hell of a lot of information here that you could map to straight out of the box. And to map to these, it's actually, I can't remember whether I talk about this. To map to these, it's actually really easy. All you need to do is create a parameter inside Revit that has the same name as these like parameter names. So any one of these which nobody can read. So we've got like glass thickness 1, is coated, translucency, reflectivity, shading, solar heat gain transmittance. All the kind of information really that you might find in a regular schedule. There's probably information on property sets available which will cover, I'd probably say 95% of those instances. Of the other instances, you can define those as well. So what information that actually exports depends on the settings that you use. This is on one of the tabs of your IFC exporter. There is a tab that says Export Revit Property Sets, and this will export out everything inside Revit. This is not good, BIM. This is not good IFC, and will give you a really ugly file. So what it will do is it will create its own property sets based on the objects or elements, and it will export out loads of stuff into all different places. It doesn't just put it randomly. There is some logic to it, but it's the fact that you can't control what not to export. So if there's parameters in your files that actually you don't want people to access at a certain stage of your project because it might be residual data that you're just leaving inside a family and you don't want other people accessing that just yet, or it might not be up to date, then all that information will come through to the IFC using this method. Instead, I strongly recommend using the very first one, using the IFC common property sets, and this is the ones that we saw in those property tables. So anything that is named based on the property sets, those parameters, like the solar transmittance, will come out into the appropriate place. There's no need to do any fancy mapping. All you have to do is just put the parameter inside your family. Doesn't matter whereabouts it is, and it will come out to the IFC. You can also define your own particular property sets as well. So Kobe, for example, there's a good portion of the Kobe parameters that that are required, things like your warranty information, that isn't actually part of IFC and is actually an additional kind of subset, and hence the reason why it's a model view definition, a separate model view definition from everything else. So in this instance, we've exported out some Kobe parameters, and these are in their own Kobe property set. So just going to go into how we do that. And using the exporter, we define the, we check the box that says use defined property sets. We select a particular text file that we can see there. And out of the box, as an example, the Kobe FM handover. This is a model view definition, as I talked about earlier on. And they actually provide the mapping file inside the exporter, and it can be found at this location. If you open this, this is a really good template or a guide to kind of show you kind of how these mapping files are set up. Again, this is tab delimited, and just going into a bit of detail very briefly. It's broken down into different sections. We have the property set delimiter, which essentially just might talk a little bit more about that. It basically just says that it's created a new property set, and then the property set name itself, whether that property set is instance or type based, and then the element that it's relating to. So you can define elements for, you can define property sets for spaces, for particular object types, or for just elements in general. And then what's included within those property sets, we have the IFC property name. So as you want it to appear in the IFC file, the parameter type, so whether it's text, Boolean, area, integer, and then you have the Revit parameter name. Now the Revit parameter name can be whatever you want it to be. It's whatever you've called your parameter inside Revit, and it'll just search for the parameter by that name. So as an example of some kind of out-of-the-box mapping, we've got some MBS content here, which contains plenty of Kobe information, and that can be mapped out appropriately into the correct place within IFC. So you can transfer a heck of a lot of information over if you choose. So actually, if you are going to use this exporter, use the exporter and create your own mapping tables, the name that you use for your parameters is pretty much irrelevant. So you don't have to be bothered by other organisations telling us, oh, you must not prefix your parameters with your company organisation initials or whatever they may be, because especially if IFC is one of the key deliverables, because you can ensure that regardless of what the company parameter name is, it can actually be exported out to the same IFC name. So what you can actually do is you can set up, if you're working on a project, you can set up a class mapping file, sorry, for your data mapping file, and set it up for all the organisations. So you can have company A parameter name, company B parameter name, and map them to the same IFC parameter. So strongly recommend that when you're working on projects that you work through this, at the very start of the project you define this and document this within your BIM execution plans. So classifications, a lot of people are using classifications more and more now on projects, NRM1, Uniclass, a whole bunch of Uniclass codes, BS 1192, and certainly in the latter stages for FM and handover, SFG 20. So these are crucial on projects for whole different reasons, whole different kind of BIM uses. Certainly from my perspective, when we work on projects, we use the classification codes as a form of grouping objects for clash detection, so we can be more specific in terms of, as we talked about earlier on, the level of granularity of mechanical equipment as a prime example. You can define basically these can only be defined at kind of object or elemental level inside using the exporter. but each object or element can belong to multiple IFC classifications, or classification. You can define multiple classification references, and to do so, it's using this convention at the bottom. So for the first one that you want to define, it's called classification code, the parameter name. For the second one, it's classification code 2 in brackets, and 3, 4, 5, and you can carry on. Do note that there is no classification code 1. So, and you have to, the parameters do need to be named like this currently. There is another way, but you can only map one, and I wouldn't recommend it. This is probably the best way of doing it anyway. And here's an example of applying multiple classifications to a particular object, in this case an external door. So we've applied product code, system code, and also an RM code as well. So we're using this this format. So it's classification name in square brackets, then the value space, and then a colon space, and then your description. It doesn't matter about whether you've got spaces for your description or anything. It just looks at the format. And exporting out, that then comes out as a genuine kind of IFC classification reference, and something that if you're using Celebri is kind of really valuable information. Also as well, obviously from an FM perspective, this will be really valuable as well because all this is clearly being defined and it's in a standard location. You can define additional. It talks about the classification reference. These belong to what's known as IFC classifications, and some of this information can be held within the IFC exporter, but unfortunately you can only define the information for one IFC classification, which is a bit rubbish. Hopefully somewhere down the line Autodesk will expand on this and give a little bit more flexibility and control. In terms of classifications, you saw that we kind of combined everything. You can use tools like the classification manager, which is again another free tool from Interoperability. You can find it at interoperabilitytools.com. If you just search classification manager Autodesk, it'll take you there anyway. And you can use this to add classifications to your project, but it will add one line for the number and one line for the description. That's where you need to use something like Bimlink or Dynamo to concatenate all this information and put it in the right format. You could use something like key schedules as well, but I personally find the classification manager the easiest route to go. I would like there to be better links between the classification manager and the IFC exporter. I think both are really valuable and useful tools. I think probably the easiest way to do it is probably from the IFC exporter side rather than the classification manager. Next up, zones. Zones aren't really something that exists in a object sense inside Revit, but in an IFC sense, the ability to kind of group different spaces or rooms, for example, depending on particular functions. So it could be for circulation, for letting, for fire, that sort of thing. So just a few examples of kind of how you might kind of group your spaces. And this sort of information is really useful for, is very key for your facilities managers. So they might want to group spaces depending on which ones are classrooms or which ones are educational spaces, or which front of house, back of house if you're dealing with retail, that sort of thing. So as I said, the concept of zones doesn't exist inside Revit, but using the IFC exporter you can define some. In a similar way, it's about adding some parameters to your project, so zone name, zone description, and zone object type. And you can actually define multiple zones. So we have an example here where we've defined a habitable rooms zone, and we've called this like zone 1, and fire compartmentation, So we've defined two zones here, and then these will export out to IFC. As I said, it's not something that Revit kind of supports natively, the whole idea of zones, but unfortunately, as a result of that, we have no object that we can actually append or attach additional data to, like we can do other things in using our mapping tables. So it's not really possible to add any of the other kind of information to it. Things like the property set, zone common, there's some additional information and data that exists within there, but due to limitations of Revit, can't do that currently. It would be good. Anybody use the Kobe toolkit? Got a few, yeah. I don't like it, but still. Certainly the way that handles zones is really good. You basically create your zones and drag and drop the spaces that belong to them, and then the kind of toolkit does the rest. It would be nice if the exporter kind of integrated that really, but the exporter currently is very much kind of a last stop before the file comes out, whereas if this kind of was more integrated inside Revit, it'd be far better workflow, I think. Levels and building stories. So as I touched on very briefly earlier on, a level is the same. A level inside Revit is the same as a IFC building story, but you do have to specifically define them. And we've got some examples here where we're exporting out and this is what this should look like. It shouldn't be big long descriptions. So it's just like the reference for the level. So B1, ground floor, and you'll notice it's all aligned to BS 1192 2007. IFC building stories, you define this inside Revit. If you've ever seen the parameter that says building story, you know now this is what it's for. Using this, checking this box actually tells the exporter that this is actually a building level. Certainly something that should be exported out to IFC. If you don't check this for any of them, then it'll export out all your levels. Alternatively, if you wonder why some levels don't export, it's because it may not be checked and some might be. So this is a good place to check. Additional information, so IFC site information, IFC building information, all this can be defined at the project information level inside the file. Again, some of this is done by default, so things like your building name comes from your building name parameter, which is native, but you can add some additional IFC ones to control your site and building information down there, such as like your building ID, is it landmarked, so that might be particularly important if you're working on listed buildings, that sort of thing. You could imagine how that could be really useful if FM team is dealing with an entire estate and they want to know which ones are listed, for example, and then that would be a very quick, easy way to use the data that's being embedded within these IFCs to kind of reference or certainly view their entire estate in a very quick and easy kind of big data way. You can define some additional information regarding the project information through the exporter, and if you change these settings, just on the kind of general tab, that you've got like things like file, header information, project information. This is where you can define the owner, the IFC owner of the file. So again, something that could be used for things like Kobe, and you can define the project address as well. That will override, if you choose, some of the information inside the project information. So just to kind of wrap up these sections, so watch points. Who uses shared nested families to speed up their workflows? Yeah, it's really good, isn't it? Yeah, it doesn't work for IFC. So if you try exporting out to IFC and you're using your shared nested, let's choose doors for an example. If you have your shared nested door panels, frames, you export these out to IFC. Your door frame will come out as a IFC door, and your door panel will come out as an IFC door, and these will all come out as individual elements. So your door handle will come out as an IFC door. So I wouldn't recommend using shared nested families, certainly for things like doors. Probably hear there's probably a bit of a drone there. People have to go back to the office and start reconsidering their content, but again, obviously it depends whether IFC is important for your workflows. Do watch out if you upgrade between versions of IFC. Some functionality kind of drops off, other stuff gets replaced. I'd probably consider the IFC exporter as being permanently in beta. It's always in evolution, there's always new things being added to it, and you do need to be careful kind of as and when you use it. If you're dealing with buildings with really complicated facades, stadiums, that sort of thing, if you're lucky enough to work on buildings that look like blobs, then you need to be really careful with the IFC as well. It doesn't necessarily have to be kind of like that large scale, really complicated geometry. In that sense, I've certainly seen recently manufacturers' content in terms of toilets, that those won't export out. I think it's probably something to do with intersecting geometry inside the families or something like that. If you're working on really big models, be really careful when you're exporting out. I have heard reports of geometry going missing and other instances where it just won't export at all. If you are working on those instances, really big projects, we're talking where the IFC would be like 750 to a gig or something like that, then you may need to consider breaking up your model before you export it out. And currently structural connections, as far as I'm aware, is the only thing that won't export. So sorry for the structures guys. Watch points and kind of criticisms really. There's a lot of companies out there that offer content and a lot of like websites as well. So like BIM Objects, BIM Store, MBS, even like Autodesk Seek, which is now BIM Objects. All these use shared parameters inside their families and contain data. But one of the issues is none of these are actually standardized. I suppose this isn't necessarily an IFC gripe, this is just general gripe, I suppose. I'm in the right forum. I'd much sooner see a standardized set of kind of shared parameters across the industry, and certainly kind of people starting to adopt like IFC, the core kind of IFC parameters, the ones that I said were part of the property sets. Revit, as we talked about, it doesn't fully support like IFC zones. I haven't really talked about IFC systems, but Revit doesn't. Revit Export doesn't support them in the way that UK COBE requires them. It will export out MEP systems, but BS 1192 Part 4 requests that every element should belong to a system. And unfortunately, Revit doesn't support systems in that sense. So system families are limited to MEP stuff only. Only export what you need. It'll ensure a greater success for the export. Do use work sets to control the visibility of stuff. If for whatever reason you work on a project where you're not using work sets, use filters, I suppose. There probably aren't that many out there. Check it. How many people export drawings to DWGs and never check them? Yeah, nobody's admitting that. There's a couple. Yeah, IFC, you're exporting out to one file. So why wouldn't you just open it just to make sure everything kind of appeared right? I'm not expecting you to spend hours and hours and hours. Just at the very least, just make sure it's there. What I haven't talked about here today is all the individual kind of settings on the exporter. I didn't want to bore you even more than I may have done already to talk about all the individual bits. If you want to know about those, there's an entire guide on the Autodesk website that explains what each one of the checkboxes does. It's been, I think it's only really been added there in the last year or so. So that'll kind of explain kind of what you may need to do. Ensure that you're not working on the cheapest machine in the office. There's enough RAM to deal with it. IFC export is relatively large in size. We talked about like class mapping and data mapping, that sort of thing. Try to set up a workflow if you can where if you use the IFC parameter names as they appear within the property sets as default, then it'll speed up your export processes, and because you won't have to deal with class mapping and all that kind of side, it's really good practice. So all the pset parameters, if those were your default parameters and you built your schedules around those, then you would have some really good solid content. You'd export out to IFC easily. You wouldn't even have to create a kind of a mapping table. But where mapping tables are required, try to standardize it. Standardize your layers, your layer exports across all your projects if you can do, especially if they're aligning to one particular standard. And when you're working on projects, if you are developing a kind of core workflow for going out to IFC, make sure it's documented and make sure you share your property set information and your mapping files so everybody's using the same one, so you can ensure the information goes out to the same place. If you do come across issues with the IFC exporter, Autodesk are really good in listening. Angel Valles and his team will respond to majority of queries and questions and issues, providing you're not just being abusive. Yeah, and they're very keen to develop this. They're a really dedicated small team within Autodesk and work really hard to kind of improve this at every single release. Some of the limitations are through the API, it's not necessarily through the exporter, so sometimes you've just got to cut them a bit of slack, and sometimes the main Revit development needs to move first before the exporter can move on. So to conclude, develop a template that contains the IFC parameters as I talked about. This is a really good workflow. IFC, there's so much data that you can potentially embed based on the IFC standard without having to create your own custom property sets. Just ploughing your way through the IFC website, you'll be able to see in the particular instances or disciplines that you work in, it will probably cover, like I said, about 90-95% of the instances. And in terms of IFC export, you can do it from Revit, you just got to be really patient. It does require quite a bit of trial and error initially, but once you set it up, you can get some good results. And if you're very keen and kind of back the OpenBIM workflow like I do, then it's kind of strangely rewarding. So thank you very much. Do we have time for any